So, welcome back. Here's your brand new video that will be on the next section, 5.2. I'm sure that you would have by now already checked out the review video. I gave you a review document to work through. Follow me in the video. And now your regular packet that we've been working through prior to this whole mess and being off since spring break. You're going to open up your packet as if we did that in class, and we're going to continue, pick up where we left off, which would be 5.2 is the next section. So let's get started. Let's get this. You don't know what I'm doing. I'm going to share my screen. So I'm going to put the camera on. And this is what I'm looking at, which you should as well. Now, leading up to 5.2, there are some things in here that's called verifying trig identities. I'll describe to you what that means when we get to the ones in 5.2, but to actually do them, you're not going to. This would be something maybe out of 5.1 in particular. Of course, you don't have any homework there, but when I test you, which will be on this stuff will be test number 3. When I test you on that, it'll be multiple choice, and these require that you show me steps, works. So don't worry about it. Not doing this, not even 5.2 anyway. Here's 5.2. Now, chapter 4 was all about right triangles. Now we're getting into things that eventually won't be right triangles. They'll be triangles, but won't be necessarily right. We're going to start off with taking a look at functions. And so sometimes instead of formulas, we might call these identities. So instead of formulas, identities. And remember, maybe a famous one, famous, F-A-M-O-U-S. Famous one, we might have called it one of the 3 Pythagorean. It's the probably most famous of the 3. Would be cosine squared, variable theta x. Let's do x, and then plus sine squared x is equal to 1. So that was an identity as well. And we had other ones, but today we're going to take a look at what they call sum difference identities. And as you can see, that the left-hand side of this one is equal to 1. Doesn't matter what the angle is. Over here, it says if you have 2 values of an angle right here, which we're going to do some examples, then the answer for this would be the same answer as these little pieces broken down. And you might even say, why do we even need this? Well, for instance, if I go down here, cosine of 15 degrees is not on the wheel. So all the ones that I showed you before in chapter 4, those are all on the wheel. That one's not on the wheel. And you can't just say because 15 degrees is half of 30 degrees, so the answer to this is half of whatever the cosine of 30 degrees is. You can't do that. It doesn't work. So this one here, one of these, well, probably, not probably, you only have 2 choices for cosine, either adding or subtracting. I'm going to come up with 2 angles. Put this on for you, and I'll describe to you what we're going to do. Okay, so what you want to do is come up with 2 angles that either add to 15 or subtract to give you 15. That could be on the wheel. Add to 15, subtract to 15. I don't know easily, I mean, I have answers of 2 angles that would give you 15. You would say something like, hey, how about 5 degrees and 10 degrees? Those are not on the wheel. What if you came up with two answers, two angles that you subtract were on the wheel? Like, yeah, 45 and 13. That's dumb. 45 and 30. So 45 minus 30 is the 15. And 45 and 30 on the wheel. How about 60 subtract 45? Isn't that 15? How about, let's see, 150 is on the wheel, degrees, and 135 degrees is on the wheel. So if you subtract that, there's another 15 degrees. So you have a lot of places. Pick the easy one. Probably what I'll do is 45 and 30, demonstrate to you. So how we're going to do this is we're going to go, okay, I'll zoom in so you can see this. We're going to go cosine. So instead of 15, we're going to go 45, I think is what I said, subtract 30 degrees. 15's not on the wheel, 30 was. So that gives me my 15. So when I look back up here, right here, number 2, see? So alpha, alpha, beta, alpha, beta. This is my alpha and this is my beta. Now it's just a matter of plugging and chugging. Plug 45 degrees into the alphas right here. And then you plug in 30 degrees in for the beta, right there. And I'm just following this formula. So here we go. Be a cosine. Okay, I'll write out the formula again for you so you can see it. Cosine alpha, cosine beta. And that would be, according to the formula, is plus sine alpha, sine beta. So 45 degrees right here is going to go here and there. All right, now, beta is right here. Forget the negative sign. Beta is right there, 30 degrees. It's going to go here and there. So that's 30 degrees. Don't forget your degree marker. And then, of course, you can go ahead and evaluate this from your wheel. This is square root of 2 over 2. That's a multiplication, by the way. This is multiplication. Multiplication, multiplication. So root 2 over 2 and cosine of 30 is root 3 over 2 from your wheel, and root 2 over 2, and then times, okay, sine of 30 degrees is a half. And then when you multiply straight across, you get, what is that, root 6? Root 6 all over 4. Plus root 2 over 4. The back of the book might push that together as one fraction. That's probably the back of the book's answer. And if it's a multiple choice, take a look. It might give you variations of the answer in multiple choice. It might give you this. It might give you this. It might give you maybe factored form. You have to play around with it. And if it's on an answer for multiple choice, you don't see either one of these, you might want to take one of the answers and put it back together again and see if you get something that you have. Anyway, so how do I know if this is true? Because this is called exact, by the way. This is called exact. Exact values. Not a decimal approximation. This one, the only way that I have to find that is a decimal approximation. So if I turn this on, look at the mode, yeah, I'm in degree mode, and then second quit, and I go cosine of the 15 degrees, I get the decimal approximation of about, it's 2 decimal places, 0.97. Right here. Now, if I put this in my calculator, it should also give me 0.97. So I'm going to put this in my calculator and see if I get the same 0.97. Yeah, that song that I played for you, some of you, well, you're so young, you may not recognize the name of the band, but you recognize the song, maybe? That was Crosby, Stills, Nash & Young from Woodstock. Just title was Woodstock. Back in the 60s. All right, so scoot that. Okay, so then I've got to go plus second square root of 6, no, 2. And that's all over 4. Well, looky there. Identically the same. Yep. So what you're trying for is exact. You're not doing the decimal approximation. That's what you're trying for. Yeah, right, kind of big. So this one here, okay, I'm gonna use a sine. So the sine choices are these two right here for the sine. All right, 75 degrees not on the wheel. We know that. Can you come up with 2 values that add to give me 75 or 2 that subtract to give me 75? Let's do the add. Let's see, your brain is probably thinking 30 and 45. Mine too, 30 and 45. So let's try that. So sine of, you might say, could I do 45 and 30? It doesn't matter, you're right. Either one. All right, let's do 45 and 30 instead. Yeah, it doesn't matter. And so this is your alpha. This is your beta, in this case. And we want that one, number 3. Number 3. So I'm looking here at the little formula. We got to start off with sine of alpha. And so that's sine of 45 degrees. And then times cosine of the 30 degrees. And then put a plus sign. And then cosine of 45. Okay, and then finally sine of what, 30 degrees? And from the wheel, you just find out that that's root 2 over 2 times cosine of 30 is root 3 over 2 plus, again, root 2 over 2 times a half. So ultimately, it looks like root 6 plus root 2 over 4. Hey, it's the same answer. You might think that's weird, but hey, it turns out to be the same answer. Check it out with the decimal approximation. Sine of 75 degrees should be the same as that. Sine of 75 degrees. Yep, looks good. Okay, next page. Okay, not that one. Next page. Similar problems. Okay, got a tangent one. Now you have 2 choices for tangent. Again, you got these 2 choices for tangent. So can you come up with 2 answers or 2 angles that either add or subtract to be 105? Because 105 is not on the wheel for exact values. I'm going to try adding because it seems to be easier than subtracting. How about 65 and 40? Yeah, but neither one of those are on the wheel. Neither one are on the wheel. Well, then how about 1645? That works, 1645. So tangent of 60 degrees plus 45 degrees, and we just follow the bouncing ball, which I'm going to put this back up. I'll put the original formula up here. So I'll rewrite this over here. Remember, this has got to be tangent. If you look at your packet, you'll see what I'm doing. Okay, so this is your alpha, and this is your beta. So here we go. Okay, I need a fraction. So tan of alpha, that'd be tan of 60. And then subtract tan of 45 over 1 plus tan 60, tan 45. That's multiplication. And now we use the wheel to come up with your exact answer. All right, tangent of 60. Look at the wheel. Where's my wheel? I need an example of the wheel. All right. Well, sometimes I don't remember these, memorize these at all. So I'm looking in my packet. You'd think I'd have this ready. Oh, here it is. Hey, we're all doing this, and this is all new for me. Yeah, anyway. What do we? We want tangent of 60 degrees. I'm looking for 60 degrees, which is up here. Okay, tangent's y over x. So I see, and the 2's cancel. So root 3. So this one here would be root 3 minus. Okay, 45 degrees, the cosine and sine, the x and y are identically the same, so it would be 1 when you do the ratio. Down here, you'd have 1 plus, okay, tangent of 60 is still root 3, and then times 1. So finally, my answer would be root 3 Okay, now on this one, that's a crazy answer. The back of the book, that might be it in the back of the book. On the multiple choice exam, might be it, might not. The other version, and we talked about this at the beginning of the semester, I didn't need, before this all stuff has happened to us, I didn't need you to rationalize the denominator. I didn't need to make that radical go away. But now you have to remember how to make that go away in case the answers are no radicals in the denominator. And so to remind you how to do that, you would do this. It's kind of messy, long. So it's called the conjugate. And so yuck, okay, but that's the process. So what I'm gonna do is FOIL the numerator and the denominator. Some magic stuff will happen in the denominator. So if I FOIL the numerator, I've got root 3, and root 3 times root 3 is root 9, or 3. So subtract 3, subtract 1, and these two multiply the last. Remember, okay, it was first, outer, inner, and then last. So minus, was that root 3? No, plus. 2 negatives make it positive. Root 3. Down below, first is 1. Okay, outer and inner, they cancel. Negative root 3, positive 3, gone. And then you get the last, which is minus root 9. Okay, you've got 2 root 3 at the top. Subtract 4 all over 1 minus 3. Yeah, this is messy. You've got 2 root 3. Boy, I'm just jumping right into the space of all these other ones. Subtract 4 all over negative 2. Yuck. Back of the book probably is going to say, you know, from here, get the negative out of the denominator. That's first. And then the 2's will reduce here. So that's nice. That's 1, that's 2, and there's still a negative, meaning that there's root 3 subtract 2 over negative 1. This means change the sign to both. So maybe that's the answer. Maybe the answer to this decimal should be the answer of when I first started that up there. So just be aware that the multiple choice answer on the test might not look like that. And you'd have to go through a process, be careful, mistakes. That would be the answer. Wow. Okay, that's a lot of work. All right, now what do I do? Oh, right here, radian. See if I can make that go into this space. Now the radians tend to be a little more challenging because degrees, I can do that in my head. You probably could too. Come up with 1645. I can't do that easily. So what you might want to try doing is choose, let's just randomly choose values like, let's see, pi over 3. Let's try pi over 3s or pi over 6s. Come up with ways of writing this so that you'll end up with a pi over 6 or pi over 3. Boy, that sounds confusing. Like this, 5 pi over 12. Let's subtract. If I do 6 pi over 12, that's a pi over 2. And then I have to subtract 1 pi over 12. Yeah, that won't work. Let's do the following. Okay, this might be easier. Take pi over 3 and convert it into 12ths. Yeah, this is a lot easier. Top and bottom by 4. Okay, 4 pi over 12. Yeah, I like this idea. And then pi over 6 is a common one. Change that to 12ths. That's, what is that, 2 pi over 12? Okay, could I add or subtract these to give me 5? No. Okay, and then how about pi over 2? Multiply top and bottom by 6. Let's see if that works. 6 pi over 12. So what I'm trying to do is find a 5 pi over 12 with combinations of either adding, subtracting. Nope. Adding, subtracting. Nope. Adding, subtracting. No, I'm not seeing it. Yep, not seeing it. Pi over 2, pi over 6, pi over 3. How about pi? Okay. Pi. That would be 12 pi over 12. No, I need an odd numerator to give me an odd. Yeah, no. So can't do this right now. I don't see it. Maybe you can. I don't see it. Let me know in your study sessions if you're able to find that, because I just don't see it right now. Can't do this now. But you ought to try and maybe take a look at the author. He probably has 1 or 2 in the radian mode. Okay, E. That stuff over there. And these two right here look different than the other ones. What you're going to do is go backwards. See, the version looks like this. I'm going to pick one of these that kind of feels this way. Cosine, 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 cosine. Hey, cosine, I got 2 choices, cosine, cosine. Do you see the plus right there? Plus. I'm going to pick version 2. Version 2. And version 2 says you're going to take the alpha and subtract the beta. See, because you don't have on the wheel 70 degrees. So maybe if you went alpha, this is your alpha and this is your beta. You go 70 degrees minus 40 degrees. Yeah, that's nice. Wheel says it's root 3 over 2. There's your answer. So that was a lot easier than the other way around, but you have to find the right one. Okay, oh, this one here doesn't look like the right-hand side, it looks like the left-hand side. Okay, oh, right here, number 1. I'm gonna do number 1 because that's my alpha plus beta. Yeah, this is my alpha, this is my beta. So cosine alpha 135. Uh-oh, I'm going to run into my my wall over there. Let's do it this way. Cosine 135 degrees, and then times cosine of 30 degrees. And for number one right here, I have to do, let's say, subtracting. And then I do sine of alpha, which is 135 again, and sine of 30 degrees. And let's see, what do I have? I've got, oh, I have to look at the wheel again because I don't have that one memorized. 135. So here's 135. It was a cosine, so it's looking at the x. So you have to take the negative root 2 over 2. You have to take the value right there. So negative root 2 over 2. Cosine of 30, I have that one memorized, root 3 over 2 minus, okay, sine of 135. I think that was positive. Yeah, there it is right there. That's the sine is the y value. Remember, this is your x and this is your y, and y is equal to sine. Y is equal to sine. So sine of 135 root 2 over 2 times sine of 30 is a half. Multiply straight across. Minus root 2. Yeah, you're always getting, it looks like a bunch of root 2s and root 6s and a bunch of 4s. Just depends on what the signs are. Squish this together. Be careful, easy mistake. That's not negative root 8. You can't do that. So this is minus or negative root 6, subtract root 2, all over 4. Nice looking answer. Okay, and I think there's one more here, and then we'll be done with my instruction on 5.2. So again, exact value, and I want to use a formula. This is a formula on my sheet anyway. Might be different labeled in the textbook, but that's formula. It looks like number 3 that I'm going to use. So this one gets students kind of messed up a little bit because there's some work. Draw a picture. Draw pictures. It's going to always be helpful. So for the alpha picture, and then there's a beta picture. So I'm going to look at this statement. Sine of some angles positive, which is true. So you're going to draw here, here, and sine is what? Opposite, OP all over, what is it, hypotenuse? So from this angle right here, this is called alpha. This would have to be the 3 over 5. And then you find the other side, likely you're going to need that. That's a 3, 4, 5 triangle, or use the Pythagorean formula if you need that. Over here, this says, okay, beta's in quadrant 2 over here. And sine, positive or negative over here. Let's see, A, smart, trig, class. Oh, sine's positive. Sure enough, I typed it out right. Positive value, not negative. Angle, this is your beta. Again, opposite, it would be 5, and this is hypotenuse is 13. And then you'll have to do the Pythagorean theorem on this, but it's 12. Actually, it's negative 12 because remember, it's this side of the origin. So here we go. You can't find this from this form. You can't do that. Just can't. And you are not putting 3/5 there and 5/13. You don't do that because alpha is not. See, it doesn't say alpha is 3/5. It says sine of alpha is 3/5. And you cannot do this. No, no, no. No, no, no. You can't make it look like this. You can't. So don't make that mistake. What you can do is convert this into your identity, which is number 3 right there. I'll write that version to the right. Oh, I wish I was in Hawaii right now, in Mauna Lanai, quarantined or shuttered in place or sheltered in place there, and smelling the ocean breeze. I guess I can only imagine. Put on some Hawaiian music. Maybe next time I'll put on some Hawaiian music, now that I'm thinking about it. No, I'm stuck in my garage at home. Well, stuck. It's not a bad thing. Making the best of it. Hopefully you are too. Making the best of it. And try to get out, get some fresh air when I can. Okay, I'm going to zoom in here, and this is what we're going to do. Now, I need to know what sine of alpha is, and guess what? I gave it to you. See, way up here, sine of alpha is 3/5. Or you could look at this and just figure out what the sine of alpha is. It's opposite over hypotenuse. That's a times. So this right here is 3/5 times, and that right there, cosine of the beta. Oh, I have to go over here for the beta. Cosine of beta. Okay, it's adjacent over hypotenuse. That's 13 over negative 12 plus. Now I'm back over to alpha, which is right here. Cosine is 4 over 5, 4 over 5 times. Oh, slide back over to beta. That's this triangle. And the sine is opposite over hypotenuse. Oh, okay, so 5 over 13. And the rest is arithmetic. Multiply straight across. Oh, put the negative up there, I guess. Multiply straight across. That's 39 over 60. Multiply straight across. 20 over 65. Is that right? Yeah, 20 over 65. Well, it looks right. Yuck. Feels like I did something wrong. Oh, you're saying you did something wrong, Jeff. This is wrong right here. See that? Yeah, you're screaming at me in the, Jeff, stop, you did something wrong. Yeah, it's adjacent over hypotenuse. I might have said that, but I wrote it wrong. That's negative 12 over 13 right here. So I'm going to have to erase it. Yeah, silly me. I sometimes even here make careless mistakes. Erasing that. This should have been negative 12 over 13. Yeah, that makes sense because the denominators will be the same, so much easier anyway. Minus 36, that's a 6, all over 65. That's a 6. Okay, so subtract that, if I did that one right. Minus 16, it looks right, over 65. Reduce that if you can. Don't think I can. Yeah, I can't. That's it. Okay, so there you go. That's your 5.2 lesson for the day. The idea is you're going to look at this, work out your packet problems, do your homework, try that as many as you can. And then when you come into class, our class study session, you could ask me questions. I'm not going to redo all these things in the packet, but I will answer questions that you're stuck on. Okay, until next time. Oh, aloha. Until next time. Okay, see ya.